Namaste everyone, welcome back to my channel. This is Sucharita B studying computer science in Sri Venkateshwara College of Engineering. Today we will be talking about RSA application in public key encryption. So, what is RSA? RSA algorithm is an asymmetric or public key cryptography algorithm, which means it works on two different keys. The first one is public key and the second is private key. So the public key is used for encryption and it is known to everyone. Private key is used for decryption and must be kept secret by the receiver. So how does this work? So basically, if a person A wants to send a message securely without letting anyone know to person B, then person A encrypts this message using person B's public key, and then person B decrypts the message. That means he decodes what and all it is sent using their private key. So RSA algorithm, just I will give a brief information on how it works. So it is based on factorization of large number and modular arithmetic for encrypting and decrypting the data. So it consists of three main stages. The first one is key generation, second one is encryption, and third one is decryption. So in key generation, you create this public and private keys, that is creating public and private keys. In encryption, the sender encrypts the data as in public key to get the ciphertext. So in this, like the person A who is encrypting the data and sending it to the person B. Third stage is decryption, decrypting the ciphertext using private key to get the original data. So this is the person B who is decrypting the data which he is getting from person A. So, talking on advantages, first one is security. RSA algorithm is considered to be a very secure and is widely used for secure data transmission. The second one is public key cryptography. RSA algorithm is a public key cryptography algorithm, which means that it uses two different keys for encryption and decryption, that is public key and private key respectively. The third one is key exchange. So what happens is it is used for secure key exchange, that is, two parties can exchange a key, a secret key, without actually sending the key over the network. There are many other advantages, but for now let's talk about disadvantages. The first one is slow processing speed. RSA algorithm is slower than other encryption algorithms, especially when dealing with large amounts of data. Large key size. So it requires large key sizes to be secure, which means that it requires more computational resources and storage space. Third one, vulnerability to side channel attacks. Vulnerability means it has the possibility of being attacked. So it is vulnerable to side channel attacks, which means an attacker can use information leaked through side channels such as power consumption, electromagnetic radiation, and timing analysis to extract the private key. Limited use in some applications. RSA algorithm is not suitable for some applications such as those that require constant encryption and decryption of large amounts of data due to its slow processing speed. Now, applications of RSA. RSA algorithm is a symmetric cryptography algorithm. As earlier discussed, it operates on two different keys such as public key and private key. Public key is likely to everyone and private key remains private. The public key includes two numbers, one of which is a multiplication of two large prime numbers. RSA algorithm is based on the complexity included in the factorization of large numbers. RSA algorithm depends on the fact that there is no effective method to factor very large numbers. Therefore, it can be done by deducing an RSA key, and deducing an RSA key would take a large amount of time and processing power. In RSA encryption, a message is encrypted with a code known as public key, which does not require to be hidden. It is based on the mathematical features of the RSA algorithm. Because a message has been encrypted with the public key, it can be decrypted by another key which is known as the private key. Therefore, a set of keys which are public and private keys is needed to read such messages. The application of the RSA algorithm derives its security from factoring the huge integral component, which are the product of two large numbers. It is simply to multiply any of the figures. The computation of the original primary numbers from the sum or variable is difficult because the time it takes, even using supercomputers, is the disadvantage of the RSA algorithm. Encryption is generally used in combination with other encryption schemes or for digital signatures which can validate the authenticity and integrity of a message. It cannot be used to encrypt entire messages or files because it is less effective and more resource heavy than symmetric key encryption. In RSA public keys, two large randomly produced prime factors contribute to their complexity. The numbers and sequences are generated randomly. RSA algorithm depends on using prime factorization as an approach of one-way encryption, so its complete security premise is based on its use. So basically in RSA encryption there is no key sharing. It depends on using the receiver's public key, so you don't have to share any secret key to receive messages from others. Proof of authenticity. Since the key pairs are related to each other, a receiver can't intercept the message since they won't have the correct private key to decrypt the information. The encryption process is faster than that of the DSA algorithm. Data can't be modified. Very important one. Data will be tamper proof in transit since meddling with the data will alter the usage of the keys, and the private key won't be able to decrypt the information, hence altering the receiver of manipulation. So, some real-world examples that demonstrate the usage of RSA encryption in practice is securing email messages in email providers, encrypting messages in messaging apps and chat rooms, securing P2P data transfer, and securing the connection between web browsers and servers. Also, it can be said that these complex messages are ideally encrypted using much larger prime numbers for additional security. In conclusion, the RSA algorithm is a cornerstone of e-signing security, safeguarding the authenticity, integrity, and confidentiality of our electronic documents. So, is RSA encryption safe for the future? RSA encryption is generally considered safe for the future as long as it's implemented properly, even if the threats exist. So, to get the best security from RSA encryption, use the specified bits keys depending on the severity of your threat models. And quantum computers are capable of solving complex mathematical problems that serve as the basis of RSA encryption. Nevertheless, research is currently underway to find new public key algorithms that are resistant to quantum computing. That's it for today. Thank you.